Awesome. Well, thanks for everybody's time and attention. I'm excited today to be talking about DataPerf. As RT said, it's about building benchmarks for data-centric AI development. Now, the talk primarily focuses on three main goals. So first, what I want to talk about is why do we need benchmarks? Why are benchmarks sort of critical for accelerating development in any particular space? And then I'll talk about why we specifically need to focus on building good benchmarks in order to enable the data-centric AI movement that we're all excited about. And third, finally, I'll kind of get around to exactly what is DataPerf and how DataPerf is kind of bringing together various efforts from academia and industry to try and pull together a coherent set of benchmarks for data-centric AI development. With that said, I'm actually a faculty member at Harvard, and one of my key goals is to help both academically as well as from an industry perspective work with MLCommons, which is a nonprofit organization focusing on accelerating benchmarks, data sets, and best practices for ML. And I'll be talking about some of the work that we've been doing in the space as a collaborative effort across many different organizations on DataPerf. All right, first and foremost, let me start off by talking about why or what does a benchmark really mean. A benchmark in any given space is fundamentally a standard or reference point against which we make comparisons, right? Now, benchmarks are extremely critical. Now, this spans many different areas. However, no matter how you look at it, it's true that benchmarks allow you to fundamentally be able to make comparisons of different solutions. You have a standard reference point, and because everybody's looking at that standard reference point, we can compare whether system A is better than system B, dataset is A, or is better than dataset B, and so forth. That comparison is actually extremely important because it fundamentally allows us to make informed selection choices, without which it's really hard to know if A is better than B. And it's also extremely critical to have good benchmarks because they allow us to measure progress. Without a clear set of agreed upon benchmarks, it's hard to say if we are truly making progress in the field because you might be speaking two different languages effectively and saying that I'm better than you, but if we're not talking about the exact same baseline, well, then it's kind of hard to compare. So measurement is sort of a critical aspect that comes out of building good benchmarks. Ultimately, what it allows us to really do is it allows us to raise the bar effectively and make sure that we're making advancements in the field in a very systematic way. In order to get good benchmarks, one can't just go out and build a benchmark independently and toss it out. Because one of the issues that comes about when you're trying to build any kind of standard reference point is that you need to have a very systematic methodology that is both rigorous and fair across industry needs, which often tend to be very diverse and different. In order to be able to do that, what you really need is to actually pull together the community and actually be able to work as a community, despite having competing interests, for instance, be able to kind of get that community consensus or grudging consensus, as we often like to call it within MLCommons, to be able to kind of build that standard benchmark. Now, if we're able to do this, right, despite conflicting interests, if we're able to kind of get alignment on the benchmark, then it creates a standardization of different use cases and workloads, which is really good, because that allows fair and effective comparisons. This allows comparability across different hardware and software methods. For instance, I might have a machine learning system A versus a machine learning system B. I can do comparisons of that. I might have dataset A versus dataset B. I might be able to do comparisons against that. And that comparability really is critical for making informed choices and driving the innovation forward. And of course, I talk about things here in the context of system compromises because originally we built benchmarks around machine learning systems. But increasingly, we're moving towards data, and we want to be able to understand what are the qualities that we have in data sets. And ultimately, what we want to have is verifiable and reproducible sort of results when we're comparing anything. All right. Now, this at large sort of stands true no matter what you're talking about, right? Like, whether it's a data set or whether it's a machine learning system or whatnot, it stands true. Benchmarks are fundamental to accelerating the field. Now, if you kind of look back in history, generally, we've had very well-established benchmarks that have actually helped us accelerate the field. For instance, if you're talking about microprocessors, right, I don't know whether Intel's got a better chip or AMD got a better chip. How do you compare them? Well, we have bodies like SPEC, for instance, that actually create standard reference points that allow us to compare these processors. What do? We tend to take a bunch of code, right, which is traditional C, C++ kind of code. Then we tend to take a compiler, then we say, okay, we can lock in the compiler, we can lock in the code, and we say, okay, this is something that the machine has to run. And then we run it on the specific processor. That allows us to then be able to systematically compare whether silicon A is better than silicon B. Now, this is actually what has accelerated, much of the progress that we take for granted around general purpose computing systems. Now, this is in fact what Dave Patterson, the Turing Award winner, says that accelerated or created the golden age for CPU microarchitectures. Similarly, over the past 4 years or so, one of the things that we've done was actually created benchmarks for comparing machine learning systems, right? Where we have a complicated machine learning system stack, system including the hardware and the software. And what we did there was, in order to say if system X was better than system Y while running specific models, we said that, okay, we're going to freeze the data set, aka something like ImageNet, for instance, and then we're going to freeze a model. We might pick ResNet, for instance, or SSD, something like that. We pick a network and we pick the data set. We lock those things in, and then everybody takes that specific quote unquote benchmark and then runs it on the system. And then we evaluate how well a specific infrastructure is doing, be it for training or for inference. Now, these kinds of benchmarks have actually played a very critical role in accelerating the space, especially in ML, for instance. Thanks to MLPerf's training benchmarks, what we have seen over the past couple of years is remarkable improvement in terms of performance, right? So what the plot here on the x-axis is showing is just from 2018 up into 2022, relative performance from the best system that we had because of a good benchmark like MLPerf, and seeing what the improvement was with respect to quote unquote Moore's law, right? Because Moore's law has been slowing down. And generally, the point is that if we have good benchmarks, what we can really do is, one, make systematic improvements, as we're seeing down here. Generationally, we're seeing improvements from one point in time to another point in time. And moreover, it allows us to actually push innovation forward, right? And another good thing about benchmarks at large is that they allow us to drive progress and transparency. Everybody can actually effectively look at the data and say, okay, something got better. The key thing behind benchmarks is that what gets measured gets improved. If we don't measure it, we can't improve it. Furthermore, it drives some sort of a community consensus in terms of understanding what does the industry at large sort of value, right? Now, in the context of machine learning, obviously, it's a very complicated stack, right? In order to drive the machine learning ecosystem forward, there are many different areas, for instance, where we need innovation, right? This spans from the scale of the systems, what your backend infrastructure looks like, what your software compilers look like, what kind of algorithms are you using to actually run your models, what's the silicon substrate, what's the microarchitecture substrate for running that machine learning code, right? And ultimately, of course, though, there is data. I would argue that by and large, with the exclusion of building benchmarks of data, all the other things on the left-hand side, the scale, the software, the algorithms, the architecture, the silicon, and so forth, have actually been studied really well in the context of building systems and making sure we can understand what's better than another. But in the context of data, we have yet to have a very systematic way of improving the data sets that we have in ML. Now, if you kind of look at NeurIPS, for instance, right? What have we done over the past decade? This plot, which is effectively looking from 2012 to 2021, is showing that we have invested a huge amount of effort in actually improving the models in the ML kind of context. We spend billions of dollars, be it in academia and industry. A lot of investment goes in. But when it comes to actually the data sets themselves, it's almost an afterthought. We just take the data set, we say, okay, we took this data set and we ran ahead and we built this new sort of architecture. And that's great. But it's extremely critical that we focus on data, because if we're not careful about data, we get into some serious problems, as I'll talk about. In fact, it's only last year that NeurIPS actually had the first focused effort on data sets. They created a data sets and benchmarking track to try and improve the data, effectively trying to go after reproducibility and targeting the other half of the machine learning ecosystem, which is not just the models and systems, but also the data sets. Now, if you're not careful about data, one of the biggest problems we have is that we can get into some serious problems. Like the Tacoma Bridge is a good analogy, right? This Tacoma Bridge basically collapsed. It collapsed because of aeroelastic flutter. Now, this is basically a different approach that they took to actually building, quote unquote, the bridge compared to traditional means of doing it. And the reason it actually failed, I would argue, is because they didn't really have good test sets for evaluating how this new approach that they've taken to build this bridge actually collapsed, right? Now, the point that I'm making is that if we don't have good mechanisms, a good litmus tests around data, when data is so critical for machine learning, then we can end up with these catastrophic sort of issues in machine learning. It's well known that you can actually have data cascades, because often in machine learning systems, since everything starts with data, is you kind of progress down the pipeline of actually putting things into production where you're deploying the models on the right, what you see is the amount of potential failure points that you're going to have is going to be quite critical. And I'd strongly recommend everyone to read the Data Cascades paper because it really lays out the point about why it is so important that we take a very close and hard look at data. Now, in addition to having data cascades, another problem with not looking at our data in a systematic and a measurable, quantifiable way is that you can actually have model quality saturation. In fact, if you kind of look at some of the data sets and you look at how models perform on those data sets, you would see that the models are effectively saturating in terms of what they're capable of doing. This is not to say that voila, we have somehow cracked the code, right? It's really fundamental in terms of what data sets are we using, what our training sets look like, what our test sets really look like. And if those are not actually good enough to really challenge, then innovation itself is effectively going to stall, right? So this is why it becomes extremely critical to have not only good principled benchmarks, but to actually benchmark data. Now, if we kind of look at the ecosystem at large, we have awesome things where we have been looking at building models, right? For example, Kaggle does a good job where we freeze the data set, we optimize the model, and the infrastructure is whatever you choose to pick at it, and you can go after that. The question that we have in our head is that how do we build benchmarks so we can try and improve or optimize the data sets that we actually are working with? Since data is the rocket fuel, if we don't optimize that, everything else really is almost not going to work in practice because data is effectively driving all of that. So what we wanted to do was to build good mechanisms for actually benchmarking machine learning data. Now, we didn't try and do this from scratch. One of the things that we're trying to do is actually to bring in existing efforts that are going on in the space. People have been building good benchmarks. For example, Cats for ML is an effort from Google that actually looked at adversarial training sort of mechanisms. There's Dynabench from Meta, which has been looking at various ways of kind of looking at the training and test set evaluation. Then, of course, Andrew Ng ran the data-centric AI competition. In fact, he's part of the team that's actually building DataPerf out at scale, where in data-centric AI competition, they basically looked at Roman numerals and tried to figure out what's the best data augmentation method or what sort of like techniques are capable on the data side in order to try and improve the performance of the model. And there are many other efforts. BC Bench is an effort from Zurich and Stanford. And like that, there are lots of different efforts that are going on that are sort of bubbling up over the space. And what we are trying to do here through DataPerf is to actually try and bring all of this collective wisdom that is starting to show up in the industry and try and pull it together into a coherent fashion to try and drive the industry forward. But of course, that's just the data side. Often you also need platforms and infrastructure to be able to do this because benchmarking data, training models, and evaluating and so forth ends up being costly. So we're basically pulling in some of the existing best efforts that we have here in the community to try and benchmark data. All right. So far what I've said is we want to do benchmarking. It's extremely key because it allows us to measure progress and in fact, make progress. Then I said, we want to specifically benchmark data because if we don't do that, we can have model quality saturation issues, we can have downstream data cascade issues and so forth. So if we believe that, yes, we want to actually benchmark the data, next question becomes, what exactly do we want to do? Well, fundamentally, there are only three really primary pillars in the context of measuring data quality. First is, how good is your training data? Second is, how good is your test set data? Because your test set data is really the litmus test, right? That allows you to make a decision as to whether the model is good enough or not good enough. So if you get a poor test set, well, that's going to be catastrophic. Then, of course, the third piece is not really just the data sets themselves on the training and tests, but it's also the algorithms that are actually used to construct the data. And that's what we're actually going after here when we're talking about DataPerf. Now, this is the third portion where I'm actually going to get into what the specifics are around DataPerf. As I've said before, what we want to do in the data-centric AI paradigm is we want to ultimately improve all three core pillars, right? We want to continue to improve model performance. So we do want to drive that. But we also want to improve or focus more on the data. And we want to measure all three things because if you really want to accelerate anything around ML, you have to tackle all three fundamentally. And we're trying to shift the overemphasis that's in the model space down into the bottom rows around training and test set. This means what we want to understand is how do we improve the training data? How do we improve the test data? And when you're talking about slices of data that are critical, which parts are more important than another, right? So how do you slice that and whatnot? And there are lots of different things that are to be done in this space. It's not like just to answer these three questions, it's not like you just have three quote unquote benchmarks, and that's it, you're done. So you have to kind of systematically think about it. All right, so let's talk a little bit about the training side, right? So if you want to improve the training, what you want to do is really the two things. One is you might want to focus on how do you actually effectively create a good training data set? How do we sort of measure how you actually do that, right? Another is you might have a very noisy, large data set, something that's been accumulated. I think increasingly, if you kind of plot the historical trend over the past couple of years, what you will see is that our data set sizes have actually been getting bigger because we've been binging on the fact that more data is better, kind of a general theme, even though it's kind of becoming apparent that that is not obviously not the right mindset to have. It's a data quality. Needless to say, though, we are going to continue creating large corpuses of data. But the key question then becomes is like, which parts of that data are actually critical for us? And that's important because there's a bang for the buck. If, for instance, instead of having you train on a data set that is, let's say, hypothetically, just like 10 terabytes of data, instead if I have you just train on 5 terabytes of data and I help you still get a very good model at the end of it, which is getting very good accuracy, well, I think that's awesome because now you might have potentially cut down your training times by 50%, right? So not only are you shrinking the data down to its core set, but you're also effectively having a system side benefit because it will cost you less to train the models. So that's one way to kind of think about the training data. And similarly, we also want to understand the test set itself, because that is, as I've said, it's a litmus sort of thing that allows you to determine whether, the trained model is good enough for you to actually release this. And algorithms. When we talk about algorithms, there are many different ways to kind of slice this, right? Often when you're trying to improve your model's performance, you want to understand where is the model really struggling, right? And you want to understand those particular slices, and you want to create complements for your existing data set that focus on those weak points in order to supplement. So you want to have mechanisms or algorithms that will help you identify that those slices of data that you need. And as I also mentioned, you might need algorithms in order to shrink that large data set down to the core aspect so you can actually improve efficiency. Then of course you might have to debug the data set themselves. So what are some mechanisms where we can actually debug our data sets, specifically in the context of labeling, for instance? And I already mentioned selection. The last one that I failed to mention is run value, like data valuation. How do you say that, hey, data set X is better than data set Y? How do you know that? There's a data marketplace out there in the wild, right? Where people actually want to sell you data, but they don't want to give you the data set, and they don't want you to train your models and then figure out if the data set is actually valuable for you. That kind of defeats the purpose. But then how do you sort of, if you can't give the data, then how do you sort of convince someone that, hey, this data set that I actually have is actually very good for you? So we need to have some ways of comparing the data, and that's what data valuation is all about. All right. So you kind of get an idea that there are many different ways of slicing and looking at this, right? So in order to kind of convert this into an actionable item, what we're trying to do in DataPerf is effectively create data competitions. And the key thing here is that we want to look at different aspects of building better data sets, right? So for example, as I mentioned, the first one being the training and test set creation. How do you create that? The second one being training and test set selection, right? Where you might have a large data set and you want to select a subpiece. Data evaluation, which I just talked about, data debugging, and just also mentioned data slicing, all of which I just kind of mentioned in the previous slide. Now, these are quote unquote the fundamental benchmarks, right? Now, where do you apply them? Well, that's where the tasks come into play. There are many different tasks, right? You can imagine something like image classification, natural language processing, is something for speech processing, and so forth. So these are all different tasks you might have. And what we really want ultimately is that we want an intersection between the two, right? So we want to create this matrix of different competitions that we have that span different tasks, but with some core fundamental areas that we really want to tackle, things in yellow, for instance. And that's what the DataPerf suite of challenges is really what we're trying to shoot for. At large, this is kind of how it works. I'll talk about 3 examples of this. So what we have are, there's a set of benchmarks that we want to have. As I alluded to, there's a whole collection of them in there. So what we want to do, for instance, if we take data selection, is automatically selecting the most valuable examples. Data cleaning would be automatically selecting the most valuable labels to clean given a certain data set. And the way one would participate, for instance, in these 2 challenges would be that, they download the resources. MLCommons provides these quote unquote benchmark resources. You would develop a solution locally, right? Then you would evaluate it and you would iterate it and try to get a good solution. and then you would upload it onto one of the MLCommons servers, which is like the Dynabench platform that we're adopted from Meta. And ultimately, the goal is to create a leaderboard where we're able to showcase this. And one of the key things that we're going after here is that we really want to have artifacts that come out as a result of having these leaderboards, which people can readily adopt. Because if we do that, what we end up doing is that we end up creating a fast ecosystem where people are not just competing for the sake of competing. What people are really doing is they're competing, but they're leading to artifacts that can actually be adopted. And voila, that kind of jumpstarts this whole cycle. And that's what we're really trying to do in order to accelerate the data-centric AI development. Just to kind of touch on some examples to be a bit more specific, here's one challenge that you can imagine having that we're actually working on right now. This is in the context of vision, for instance, which is focusing on the training data set selection. And the goal here is effectively that we want to have submissions that are scored on mean average precision, very typical metric, right? But the idea is that we want to have a selection strategy that chooses the best training set from a large candidate of images, right? And that's one. Similarly, we have something that's in the context of speech, where speech, for instance, we're focusing on keyword spotting, which is shipping on billions of devices, right? And what we want to do is, you might have a really noisy large data set like the multilingual spoken words corpus, which has got over 300,000 different keywords and it supports 50 different languages. And one of the things that we're trying to do is in multiple different languages, you'll have to choose the best training set from this large messy pool of potentially noisy data. And then ultimately you're going to get scored on what those selected keywords do in terms of model evaluation. Finally, on talking about data cleaning / debugging, the goal here is to actually choose a good cleaning strategy or to come up with a good cleaning strategy that helps you identify what you actually have to fix. Now, these are the three initial challenges that we're launching. I'll talk about how you can actually get involved later on. But our vision is if we start with those three, and then you can expand that into that matrix that I showed you where you have different tasks and you have different benchmarks. Our vision is to be able to create what we call as a data ratchet. The goal is this. First, you want to try and improve, let's say, the training set. Once you move the training set, then you can use that good training set in order to drive the evaluation of the test set. When you have a good test set, then you can take that next level test set and then try and improve the training set. And this effectively, the ratchet idea is that you constantly continue to improve. You improve one, which then pushes the other to be improved better, and so forth. Now, the way to get involved is this. I encourage people to just check out dataperf.org, where what we have effectively done is kind of laid out the vision that that I just kind of presented. And what we have, there are some links down here you can check out which talk about the specifics of the challenges. You can go to the GitHub and actually check out the challenges that we have. Things are still, cooking towards the beta stage right now, but we're looking for interested parties who actually want to effectively take part in this, not only in just kind of competing in the space, but actually defining new data-centric AI benchmarks, like the ones that I kind of hinted at. Now, if you want to learn more, I also encourage you all to check out the DataPerf white paper, which talks about some of the lessons that we learned from running the initial data-centric AI challenge that Andrew championed, which we're now maturing into a much more complex space with many different challenges, as I kind of alluded to. And our hope is that as the community gets involved, we can try and systematically build benchmarks, because if we build a robust set of benchmarks in this space, what we'll be able to do is to progressively get the community involved in driving innovation in the training set and the test set. And so over the next 5 years or so, just the way the models have kind of progressively improved, we will hopefully be able to systematically quantify, measure, and improve machine learning data sets. And I'll leave you with these links if you're interested in joining, and I'm happy to take any questions you may have now.
Amazing. Thank you so much, Vijay, for that very enlightening talk. I know I'm certainly very curious about all the benchmarks and was opening up the paper on the side. So excited to dive into the details. And Cody's speaking later in the day, so excited for his talk as well. Yeah. So quick question. I mean, we will dive into the paper and I'll do that offline as well. But I am curious, how you're developing sort of evaluation strategies for a lot of these tasks. Like, is this the right slice of data to pick on? I know you touched on it briefly, but for example, I think one problem that I personally think is very interesting is also one you alluded to, which is how do you make sure your test set is actually representative of all the variety that you're seeing, and such that when you're evaluating on it, you know that you will do well in the wild. How do you design an evaluation system, for example, that works on that? Do you hand label various examples and see if the algorithm picks those up? Just curious.
Yeah, so that's kind of what we're actually, there was a real good tough challenge on the test set, because obviously it is sort of the critical piece, right?
Right.
And of course, when you think of the test set, like it really is a subjective kind of a thing, because it really depends on what question you're specifically going after, because that's what the test set has to have. So one way we're actually thinking about is this. Yes, we have some sort of golden, ground truth kind of thing that we validate. So think about it like from 3 years from now, right? We're going to have some agency, maybe it's MLCommons or whoever, is effectively creating these standardized or certification ML test cases, right? These test sets. Because a training set is kind of hard to kind of create, right? And really kind of say like, oh yeah, this is the perfect mode. That really depends on what you're trying to go after. But we could say, for instance, if you're going after, I'm just making this up, but like a security camera, for instance, what are the kind of key characteristics that a test set, what are the good characteristics a test set should have for a particular use case within, say, for example, as a security application, right? And that's the way we're kind of approaching it, because then we feel like we can constrain the space a bit. Otherwise, it becomes almost impossible to be able to actually do this. Short answer, though, in order to directly get to your point, is that we haven't quite figured it out, like in terms of what the properties need to be and so forth. So that's where, one of the key things that we're doing is asking for people who are actually working with this to come in and say, well, this is the kind of test that I would want. And the hope is that ultimately we will have bits and pieces that we collect as a community-driven consensus that everybody would say, for example, this test set indeed captures all of the different kind of scenarios that you expect to see, and everybody has had a say in it.
Got it. Makes sense. So the goal is at least to start some benchmarks, start a working group, get these groups together, and then even kickstart this process, which is, I think, a very important step towards this process. I know we have a bunch of other questions from the audience, but we are also running out of time. So if they wanted to contact you, what would be the best way to do that?
Best way would be simply look me up. You can just type in my name and then shoot me an email. Another thing would be just to check out the dataperf.org website, which has the mailing list for all the members in the group who can answer questions.
Amazing. And with that, thank you so much, Vijay. Such an exciting effort, and thank you for sharing that with us today.